Cosine is the adjacent side divided by the hypotenuse. In the previous page, we found some cosine values for some angles. We used calculator on the phone, just directly the scientific calculator that's standard on the phone, to calculate some cosines of angles. Be in degree mode, okay? Now, what do the cosine values of the angles in question 3 all have in common? What I notice is that they're decimal values, and then they're all less than 1, right? 0.6, 0.6, 0.5. All of the angles in that question produce cosines less than 1. That might be something we're going to study here. We're going to say, could it be potentially like the reverse for secant? Secant and cosine are related. They are reciprocals of each other. Is the cosine value of every acute angle less than 1? I mean, I'm going to say yes, but let's go ahead and just test it. So, yes, let's check. And to do that, iPhone calculator. So I've got the screen turned sideways, and I'm just going to do this like without recording anything, but let's just do some observation. So I already know that 53, 48, 60, all of those produce values around 0.6. So I'm going to try a different angle. Let's try 85. 85 degree angle cosine. And am I in radian mode or am I in degree mode? I think I'm going to make sure it says degree down here. 85 cosine. Nope, that's radian. 85. I know it's radian because I got a negative number. No negatives for geometry classes. Negatives will happen in Algebra 2, and there'll be a reason why. But right now, we should have positive. So the cosine of 85, 0.08. The cosine of 89, 0.01. Well, those are definitely less than 1. Let's go the other way. Let's go cosine of 25, 0.906. Cosine of 15, 0.96. Still not greater than 1. Let's check. We're checking with 89, 85, 25, 15, choosing different angles. I'm going to check with 5 degrees, like a really, really flat, like a no slope to the hypotenuse triangle. Has a cosine of 0.9962. Let's try 1 degree angle. Can't get more than 1. You will not get more than 1 with the cosine values. All angles from 1 degree to 89 degree produce cosines less than 1. We could also note greater than 0. And I'll put that right here. And above 0. Okay, maybe a little like 0 written like that. Okay, not a theta, a 0. What does this tell you about the secant values of every acute angle? When I look at this triangle, or not this triangle, this phone calculator, secant isn't listed. Secant is not listed. But I do know this fact, and I'll share it with you now. Secant of an angle is 1 over the cosine of that angle. So I can still use my scientific calculator on my phone to calculate secants. I just have to calculate the cosine first. So let's go back to cosine of 60, right? So phone, turn it sideways. And I need to know the cosine of 60 first. So 60 degrees cosine. Since I get that decimal of 0.5, the way to get the secant is to do 1 divided by 0.5. That's 1 divided by cosine 60. So for example, secant 60 degrees is 1 divided by cosine 60 degrees, aka 1 divided by 0.5, and we get an answer of 2. Let's try another one. Let's try from that page 578, let's try cosine 53. Let's find secant of 53. So secant of 53 degrees would be 1 over cosine of 53 degrees, which means I got to go find 53 cosine. Oh, here's a trick on the iPhone. You see these M's up here? They say M plus, M minus, MC, and MR. This stands for memory clear, add to the memory, take away from the memory, and memory reset. And if I know this decimal is the cosine of 53, I don't want to type that decimal in again because I'm going to have to do 1 divided by that decimal. But if I go memory plus, now memory recall is ready to use that number. And when I do 1 divided by memory recall, it's going to bring that number back like a copy paste so that I can then calculate the secant of 60. 1 over equals 1.6616. I need to clear it. I need to recall it. It was 0.6018. So it turns out the secant value of every acute angle is the reciprocal of cosine. I'll put that right here. Secant is the reciprocal. I'm writing underneath my camera, I realize. And then also look at our answers. 2, 1.66. Let's just check again here. Memory clear. Let's go cosine of 1 degree. Memory store 1 divided by cosine of 1 degree is bigger than 1. Barely, but it's still bigger than 1. So all secants are greater than 1. That's the big idea I want you to know about. Maybe you wrote it exactly like I did, but whatever. Okay, write it how it makes sense to you for using it. But secants, bigger than 1, cosines, less than 1. They'll never be actually equal to 1. What happens to the cosine and secant values of an angle as the measure of the angle increases? Let's write out the prompt in, like you take the question and you rephrase it, and then you provide your answer. So good sentence answers right now. As the angle increases, the cosine, spell it right, values decrease, and the secant what happens to the secant values? So if I did cosine of 89, I don't know where it should go here. It might be increase, it might be decrease, it might stay the same. Check it. Memory clear. Cosine 89, small number. Store it in the memory. 1 divided by cosine of 89, pretty big number. So secant values increase. And in fact, I'll let you know the secret, they increase to infinity. Like secant values will always continually get bigger and bigger and bigger, no matter what the angle is. As the angle gets closer to 90, right? We can still take angle measures like 89.9995, right? That's almost 90 degrees. To your eyes, you couldn't tell the difference. But mathematically, yeah, definitely. Look at the cosine value of that. It's really small, tons of zeros. So if I store that in memory, and then I do 1 divided by that number, it's going to be really big. 114,591. That's the answer for secant of a degree, 89.9995 degrees. So secant values will increase to infinity. Don't say and beyond. What are you, from Toy Story? Don't be a Buzz Lightyear. Okay, thank you for watching this page, page 579. More to come, talking about cosine and what it is, and secant and what it is, and definitely putting them into practice. But remember, cosine is the ratio adjacent to hypotenuse.